Hi everyone, my name is Emerald Omba and today I will be talking about Imaps and DNS. Before we start, I do want to give a quick overview of this presentation and why it matters in the real world and not just in a lab. Both of these protocols, IMAP and DNS, are like the silent workers of the internet. They're constantly running in the background, making things function the way we expect them to. IMAP is what lets us securely check our emails from one device without losing messages. And DNS is what lets us type simple names like google.com instead of long, impossible to remember IP addresses. What's cool is that these two protocols might seem unrelated. One deals with emails, the other one deals with web navigations. But they share one big thing in common. What they share in common is security risk if they're not configured and hardened properly. That's why in this presentation, I'll walk through how each protocol works, how to configure them on both Linux and Windows, and most importantly, how to secure them. I've broken things down into easy sections, an overview of IMAPs and DNS, followed by their hardening recommendations. I've also included simple memory tricks along the way to make remembering them a little easier. So think of those as sticky notes for your brain. IMAP. IMAP stands for Internet Message Access Protocol. Think of IMAP as your personal mail organizer that lives on a server instead of your device. It stores your messages remotely, lets you read them from anywhere on any device without losing your place. Pretty convenient, right? IMAP works over port 993 and is basically the secure version of IMAP. The S at the end stands for secure, meaning it uses SSL or TLS encryption to keep data private while it travels between your email client, and the server. I practice configuring IMAPs using Dovecot and Linux. Dovecot is lightweight, easy to install, and widely used for managing email protocols like IMAP and POP3. Setting it up involves editing the Dovecot configurations file to enable SSL and ensure it listens to port 993. Once that's done, you can check using Nmap to make sure the port is open, listening, even if you're not actually sending or receiving emails. Here's a little memory trick to help you remember IMAPs. I like to think of it as I've made up an abbreviation, which is basically I manage all posts securely. The phrase not only defines the protocol purpose, but also emphasizes that the final S is for security. In short, IMAP makes email access flexible and safe by encrypting communication, keeping messages stored on the server, and syncing across devices. Kind of like your email version of a cloud. So like I said, a quick and easy memory trick is I manage all posts securely. Next up is DNS, which stands for Domain Name System. If IMAPs is your mailbox, DNS is your address book. It's what translates easy to remember names like google.com into the IP addresses that computers use to find each other. Without DNS, we'd all have to memorize long strings of numbers, which is not fun at all. DNS works primarily on port 53 using both UDP and TCP depending on the type of query. I practice configuring DNS using IIS on Windows and Bind on Linux. In Windows IIS, you can use the DNS manager to create forward and reverse lookup zones, add records, and configure caching. On Linux, with Bind, you configure it by editing /etc /named.conf and zone files under /var /named. Once that's done, Restarting the service and testing with dig or NSLOOKUP helps verify everything's working. Here's a cool memory trick for DNS. I've made an abbreviation that goes like, that basically stands for don't need to spell IPs. That's literally what DNS saves us from doing. It converts names to numbers. So in short, DNS keeps the internet human friendly. It's what makes typing youtube.com way easier than remembering 142.250.190.78. Going back to Imaps, when it comes to hardening recommendations, Imaps, it's not just functional, but secure. The first recommendation is to enable SSL/TLS encryption. This ensures all communication between the client and the server is encrypted, protecting against eavesdropping and man-in-the-middle attacks. In Dovecot, that's done by enabling SSL in the 10-ssl.conf file and pointing it to your certificate and key. The second step is to disable plain text logins. You'd be surprised how many servers still allow encrypted passwords. That's like locking your house but leaving the window open. Instead, enforce secure authentication methods such as plain login over SSL or use stronger mechanisms like CRAM-MD5 or SCRAM. The third recommendation is access control. Limit Imaps access to only trusted networks or specific IPs using firewalls or host.allow rules. That way, even if someone scans your server, they won't be able to connect unless they're authorized. And as a bonus tip, regularly monitor your logs in /var/log/dovecot.log for suspicious logins. It's like checking who's been knocking at your digital door. So in short, encrypt, authenticate, and restrict. Or remember it like ear, because your server should listen securely through its ears. Finally, let's look at how to harden DNS. Since attackers love targeting it to redirect traffic or steal data, the first step is to disable zone transfers to unauthorized systems. Zone transfers are used to copy DNS records between servers, but if left open, attackers can grab your entire DNS map on bind. This is done by adding allowed transfers to your configuration file. Second, enable DNSSEC, which stands for Domain Name System Security Extension. DNSSEC adds a layer of authentication by digitally signing DNS data, so users can trust that the response really came from the right source, not a fake one set up by attackers. Third, keep DNS software patched and logging enabled, whether it's bind or Windows DNS. Frequent updates close vulnerabilities that hackers might exploit. Logs, on the other hand, help detect unusual queries or failed lookups that could indicate probing attempts. Here's a simple memory trick for this one. Safe DNS. Secure transfers, authenticated responses, DNSSEC, frequent updates, and enable logging. So the abbreviation is SAFE, but it stands for Secure Transfers, Authenticated Responses, Frequent Updates, and Enable Logging. And for a little humor, DNS is like your GPS for the internet. You wouldn't want a hacker giving you the wrong directions, right? That's why keeping it secure is so important. So again, the abbreviation is SAFE DNS. Secure transfers, authenticated responses, frequent updates, and enabled logging.